Hello there folks, welcome to video number 209. This one is on probability trees. Keywords are independent, dependent and conditional. So independent relates to the events, and independent events are not connected to one another. They're completely separate. Dependent events are events that are connected, and conditional is just another way of saying that one event is dependent upon another one happening. So in the method it states that you need to draw a probability tree to calculate probabilities when you have a combination of events. The events are written at the top above the branches. The outcomes are written at the end of each branches. To determine whether the events are independent or dependent, you have to think about what the actual events are, right, and how are they connected, are they not connected. You next write the probability of each event on the branch itself, and you multiply the probabilities across the branches to find the likelihood of a combination of events. And it's usually just two events in these questions. If it was more than that, then you wouldn't use this way of doing it. And you may need to add the probabilities of the combined events depending upon what the question is asking you to work out. It all sounds a bit more complicated than it really is in practice. So if we look at question number 1, Rosie plays badminton and then tennis. Think about those two events. Are they connected? I mean, they're similar sports, but they're not connected at all. They are both independent from one another. Different games. So this is an independent probability question. The probability she loses badminton is 0.4 and the probability she wins tennis is 0.85. So we've got a bit of information, right, which is actually written on the trees already. We've got to complete the tree diagram, get a couple of marks for filling this in. All right. Now, the only thing you need to remember here is that she can either win or lose the game of badminton. That's what this diagram is representing. All right. This is our start point over here. She either wins the game of badminton or she loses the game of badminton. You see badminton's written here. This is event number 1. So the only thing that winning could be, the only probability it could be is 0.6, because the probability of winning and losing has to add up to one whole amount. All right. These events are mutually exclusive, aren't they? You can't win and lose at the same time. Okay. And the same logic follows over here with the game of tennis, right? Now you've got a branch of winning and losing coming off of the win. Right, you've also got the same thing coming off the lose, right? Which is why you won't get more than 2 events on this, because it will just keep getting bigger and bigger and bigger, and it will just be far too big very quickly. So 0.85 taken away from one whole amount, same logic applies there, 0.15. Okay, and then this is 0.85 because I'm just trying to squeeze it in there, because it's the same thing as here, right? It's the same branch here, win, win, right? This is just the event of winning should she have lost the badminton match here. This is the event of winning should she have won the badminton match here. So it's all a bit theoretical, but we're kind of hopefully understanding as we're going along, right? So the other bit that we need to fill in is the 0.15 down here, same as it was before. And then we can get our 2 marks. That's it, done. All right, that's part A completed, filled in the probability tree. Now we can use the probability tree that we filled in to calculate the probability that she wins both games. Okay, so the chance that she wins the first game is 0.6, we can see above the branch, and the chance that she wins tennis is 0.85. And what you do is you think of the AND rule here. All right, so it's the chance of the probability she wins and then wins again. All right, so probability of a win and then a win is equal to 0.6 multiplied by 0.85. Okay, and all you have to do there is type that into the calculator and work out what it is. You could turn them into fractions if you wanted to. It might be useful to bring the calculator in if it loads up. You might have to do this without a calculator, in which case you need to know how to multiply your decimal numbers, in which case I'd do 85 times 6 and then divide by whatever you need to divide by 1,000 in that case. But yeah, probably for that one you'd get a calculator. So just type it in and then find out what it is. It's 51 out of 100, so 0.51. Alright, so she's got just over half a chance of winning both games. Okay, Now, that is a really useful thing. This would be a really useful thing to do for each question that you do. All right. So before I move on to the next one, you write it down at the end of each branch. So this is the win-win. Okay. So probability, and I can't really squeeze it in. Probability of the win-win, and we've just worked it out at 0.51. Okay. Probability of the win and then the loss. So WL is equal to, and then you do 0.6 times 0.15 to get that one. Okay, and the same for this one. The probability of a loss and then a win is equal to 0.4 times 0.85, and the probability of a loss and then a loss. All right, now that's useful to do. I'm not going to work out what these actually are because we didn't need to for this question. It's useful to do, right, because we might get other questions asked of us in these particular questions. So let's see what the next one asks us to do. Okay, I'll just get rid of those things because we didn't actually calculate anything for them. Right, so question 2 is asking us about, so it's telling us about Becky playing table tennis and then darts. Again, should be thinking straight away, independent events question, right? The probability she wins table tennis is 5/6, and probably she wins darts is 3/8. So we've got fractions this time instead of the decimals. I prefer the fractions actually, to be honest. So table tennis, 5/6, win, you put 5 out of 6 there. Right, which means that 1 out of 6 there is the loss, the chance of losing. The chance she wins the darts is 3 out of 8, so just be careful of the wording, and then that's going to be 5 out of 8, and then that one's going to be 3 out of 8, and that one's going to be 5 out of 8. Alright, so that should be relatively simple. Hopefully you understand that. These have to add up to one whole amount. These have to add up to one whole amount. These have to add up to one whole amount. These, most of the time, are going to be exactly the same as the ones above, right, or the ones below. So we've done part A again, simple. What is the probability she wins exactly one game? Okay, so probability she wins exactly one game. That's win-win, so we're not interested in that path. All right, win-lose, we want that path because that's one game. So probability of win and then lose is equal to. Now, there's another way of getting exactly one win, or exactly one win. Is a loss and then a win. So probability of the loss and then the win. Okay, so there's these two ways. Loss, loss, not interested in that path. Okay, now you could work them out, wouldn't hurt anyone, right? So let's do those two calculations, right? So we multiply across the branches. So 5 times 5 is going to be 25, and 6 times 8 is 48, so 25 out of 48. And then this one, 1 times 3 is 3, and 6 times 8 is 48. Okay, so they're the two ways that she could win exactly one game. So it's either this way or this way, right? Win, loss, or loss, win, right? And that keyword or should remind you that you need to add the probabilities together. So we've got them out of 48. We're going to add, I can't write the add symbol for some reason, there we go, 3 48s, and we're going to get our answer. So 25 plus 3 is 28, and 48 stays as is because you don't add the bottom numbers when the bottom numbers are the same. All right, or when you're adding fractions at all, in fact. So there you go. There's the answer to that one. Again, you don't need to simplify it. You could do, but you don't have to because we're in the world of probability. All right. Now, third question. The cycling team has 7 men, 3 women. Adam chooses 2 of the team at random for a drugs test. In part A, we need to complete the tree diagram, so let's fill that in, all right, and think about this being independent or dependent in a minute. So let's fill in the tree diagram first. So 10 people in total, and 7 of them are men, so 7 out of 10 there, okay, and then 3 out of 10 there. Now, this is where we have to think about it being a conditional or dependent probability question, because the second person being picked is dependent upon who was picked in the first go. All right, so we have to think about that theoretically. The probability that on the second go a man is picked for the drugs test is going to be 1 less if it was a man the first go, so 6, and there's going to be 1 less person in total, so it's out of 9. Right, now the second go woman being picked, if it was a man, there's still the same amount of women there. So that's 3, and then that's out of 9, right? Because there's still 1 less person. All right, so it's conditional on what happened the first go. All right, or dependent on what happened the first go. Now, following this branch, if a woman was picked, the chance it's a man in the second go, there's still 7 men, but there's 9 people in total. Okay, so that's 7 out of 9. And then this one would be 2 out of 9. Okay, I'm hoping that makes sense. If you think about it logically, it should really make sense, right? So let's work out the probability of it being a man and then a man, all right? This event here, combination of events. So 6 times 7 or 7 times 6 is 42. Multiply across the branches. 10 times 9 is 90. Okay, probability of a man and then a woman is 7 times 3, which is 21, and that is 90 on the bottom as well, 10 times 9. Then we've got 3 times 7 for the next one, which would be woman then man in that order, and 21 out of 90 again. And then this one, multiply across these branches, would be probability of a woman and then a woman again. Here, there is a 6 in 90 chance of that happening. Okay, so what is the probability that Adam chooses at least one woman? We can use this, what we've just worked out here, to work the answer out to this question. You can do it in a couple of different ways. You can go nice and safe here, right, and go, well, man, man, there is not at least one woman there, right? Man, woman, yep, that one works, right? We're not interested in that one. Then we've got this one, that's also at least one woman, and that's also at least one woman, right? There's 2 women there, right? So we've got 3 different ways in which we satisfy the answer to this question, and we add our probabilities together. So we do 21 over 90 plus 21 over 90 plus 6 over 90. Okay, so that's going to give us 42, and 42 plus 6, 48 out of 90. All right, or, and this is a nice quick way of doing it, we could look at the way it doesn't work, and we could do 1 minus 42 out of 90. All right, now that one whole, if we turned it into 90 out of 90, and we took away the 42 out of 90, we'd end up with the 48 out of 90 that way. Okay, so 1 in this particular question, because the bottom number of our fraction here is 90, 1 needs to be represented by 90 out of 90. All right, so there's 2 ways you could do it. You're going to get the same answer either way. And again, you don't need to simplify the answer. And that's it. All right, so I've covered independent and dependent events there for probability type questions. So we've got all sorts of different kind of variations on what you might be asked afterwards as well. All right, and it covers all the bases. Hope you enjoyed that one. Take care of yourselves. Thanks very much. Have a lovely whatever evening, morning, afternoon, whatever time of day it is. Enjoy it. Take care. Bye bye.